In this tutorial, we are going to simplify an expression into separate terms of xn, where n is a real number before integration. For this purpose, we are going to set of exercises 8D, page 139, and we are going then to exercise number 3, part H. In part H, we are asked to find the integration of 2x plus 1 all squared divided by square root of x with respect to dx. Then, first of all, in the numerator, we can see that we have 2x plus 1 all squared. Then, let's first expand this term. We have 2x plus 1 all squared all divided by the square root of x. Let's expand again the first numerator, which is 2x plus 1 all squared. This is equal to 2x plus 1 multiplied by 2x plus 1. We already know we can split the first bracket, so it becomes 2x multiplied by 2x plus 1, and then the second term of the first bracket plus 1 multiplied by 2x plus 1. Let's expand. 2x multiplied by 2x is 4x squared. 2x multiplied by 1 is plus 2x. 1 multiplied by 2x is plus 2x. 1 multiplied by 1 is plus 1. This is equal to 4x squared plus 2x plus 2x is 4x plus 1. Now let's substitute this in the fraction. We have then 4x squared plus 4x plus 1 all divided by the square root of x. We have a common denominator and we have 3 terms in the numerator. Then we can split these terms that are in the numerator and divide them by the common denominator, which is a rule that we already studied previously. Then this fraction can be written the same as 4x squared divided by the square root of x plus 4x divided by the square root of x plus 1 divided by the square root of x. Therefore, now we have 3 fractions, but we already know that the square root of x is equal to x to the power half. So now we have a common base that is x. So we can subtract the powers from each other. So we get 4x squared minus the power of the square root. It's going to be minus half. Then for the second term, it's plus 4x to the power 1 minus the power of the denominator, that is half, and finally 1 multiplied by x, and now it's minus half. We directly took the x to the power half to the numerator, so it's minus half. Therefore, we get 4x to the power 3 over 2 plus 4 multiplied by x to the power half plus 1 multiplied by x to the power minus half. Therefore, this fraction now is the same as this linear combination, where it's easier for us to integrate the linear combination. So we can substitute now the integration of part h is equivalent to the integration of 4x to the power 3 over 2 plus 4x to the power half plus x to the power minus half with respect to d of x. Now we can integrate each term in this bracket separately, knowing that the integration of k multiplied by x power n is k over n plus 1 multiplied by x to the power n plus 1. Therefore, straightforward integration for each term. Let's start with the first term. 4x to the power 3 over 2 is 4 multiplied by x into n minus 1 is 5 over 2 divided by 5 over 2 plus the second term 4 multiplied by x into n plus 1 is 3 over 2 divided by n plus 1 is 3 over 2 plus for the third term x into the power minus half plus 1, which is n plus 1, then it's half, divided by half plus the constant c. This is equal to, now we are going to get rid of the denominators or to rewrite it. So the reciprocal of the first denominator is 2 over 5 multiplied by 4 multiplied by x to the power 5 over 2. Similarly with the second term, it's 4 multiplied by 2 over 3 multiplied by x to the power 3 over 2. Third term similarly is 2 multiplied by x to the power 1 over 2 plus the constant c. Now, doing simplification, then we have 8 over 5 x to the power 5 over 2 plus 8 over 3 multiplied by x to the power 3 over 2 plus 2 multiplied by x to the power half. It's going to be the same or stay the same plus the constant c. So this is the final integration for the part h, for the expression in the part h. As you observed, we used many strategies in order to do the integration. We expanded first the numerator, then we divided the terms of the numerator by the common denominator, and finally we did worked out with indices.